Hi friends, in this session we study about the composition of functions. Let f such that a to b here is the domain of f and b is the codomain of f, and g such that b to c where b is the domain of g and c is the codomain of g. Be two functions, then function g of f such that a to c. So a is the domain and c is here codomain. Be defined by g of f of x is equal to g of f of x. For all x belongs to a is called the composition of f and g. Here you see the existence of g of f and f of g exists only when the range of, for g of f, the range of element of f must be subset of domain of g. The same way f of g exists only if the range of element of g must be subset of domain of f. So here I explain you with this diagram, and you see here this is our x, this is the domain of function f, and this is our range of function f, which is b. This is b is the range of function f, but it is the domain of function of g. Here you see it is g, so it is the domain for this and range for this f function and domain for this g function, and the range of g function is c. Look at here. So if we have to find out g of f of x, then the domain of g of f of x would be a, here it is the domain of g of f of x, and the range would be g of f of x, the range would be c. So here you see this function, I explain according to that. Here you see it is f a to b, f is a to b, here g is b to c. Look at here, a to b, b to c. Here you see g of f is a to c. G of f is a to c. I have given here the arrow or how it works. So this is a way we could find out. This is the explanation of composition function through this diagram I have explained. Now we take one example and we try to understand detail what is basically how we get the range and domain and range of these sort of functions. Now we take one example for better understanding of this composition of functions. So we have f such that 2, 3, 4, 5. The domain for f, and the codomain is 3, 4, 5, 9. It is 3, 4, 5, 9 we have. Now we take function g such that the domain is 3, 4, 5, 9, and codomain here 7, 11, 15. 7, 11, 15. So these are our f and g functions we have. First of all, we have to find out the existence of f of g and g of f. As per the condition for f of g, look at here. For f of g existence, the range of element of g must be subset of domain of f. So range of g you see here, range of g here 7, 11, 15, which is not the subset of domain of f. So domain of f is 2, 3, 4, 5. So there is no intersection of range of g and domain of f is 5. So it is not possible, it is not a subset of this domain of f. So f of g is not exist here. F of g does not exist. Okay, Now we see about the GOF. For GOF existence, the range of element of F must be subset of domain of G. So the range of element of F we see here, it is range of F is 3, 4, 5, 9 and the domain of G is 3, 4, 5, 9. So range is the subset of this domain, both are equal. So GOF exists now. Now we see how we get GOF. So this function defined as F2 is equal to 3, F3 is equal to 4, F3 is equal to 4, F4 is equal to F5 is equal to 5. Now we say another one for G. G3 is equal to G4 is equal to 7. G5, just a moment, is equal to G9 is equal to 11. So now we find out GOF. For GOF, we have to find out G of f of x. So first we find out GOF of for 2. First we find out GOF of 2. GOF of 2 is equal to G of f of 2. And this way we could write this thing. So now we get f of 2 is 3. So we have to find out G of 3. And G of 3 is equal to 7. So we get here 7. Now GOF of 3 we have to find out. So we get here GOF of 3, and this way we could write this. So f of 3 is 4. So G of 4 we have to find out. So G of 4 is also 7 we have. Now you see GOF of 4. So we have to find out G of f of 4, and this way we could write this. And G f of 4 here is 5. So we have to find out G of 5. G of 5 is equal to 11. Now GOF of 5 we have to find out, which is G of f of 5, and G of f of 5 is 5. So G of 5 we have to find out here. It is again 11. So look at here, if the domain is 2, then range 7, 3, 7, 4, 11, 5, 11. So we get the GOF. So now GOF, if we write down as per this definition, the range, the domain of GOF would be 2, 3, 4, 5. So we write here 2, 3, 4, 5, 2, 3, 4, 5, and we know the domain, codomain also. So the codomain would be here 7, 11, 15. So it is 7, 11, 15 codomain. 7, 11, 15. Now we define this function GOF. GOF can define by write GOF is equal to two 7. So I make the pair for 2 7, another 3 7, another 4 11, then 5 11. In this way we could define GOF. So this is a way to find out the domain and codomain or the range of composite function. Or we can easily find out the existence of composite function, whether it exists or not. So thank you for this session.